Good.
For the next presentation, we have Matt Brown from UCL. Let's begin. Sorry. He'll be presenting challenges in sign language AI research, the data problem. Yeah, let's give him a big applause, please.
Hello, everyone. Thank you very much to the organisers for all of their hard work today, and thank you for the opportunity to talk to you. Slight change of pace, I think, because I'm not any kind of machine learning or AI developer. I'm a sign language linguist. I work at the Deafness, Cognition and Language Centre. Historically, I've been involved with the BSL Corpus and BSL Sign Bank, both of which you may have seen cropping up in other people's work today, so it's really good to see that it's being put to good use. And I'm presenting today on behalf of myself, my colleagues Bencie Woll and Kearsy Cormier, the parent and former directors of DCAL, and also our colleague Neil Fox from the University of Birmingham, who unfortunately couldn't be here today. So I feel like what I'm about to say is probably known to at least some of you, but we just feel that it's a message that really needs to be reinforced. And it also touches on things that the previous presenters have mentioned. But again, I'd just like to sort of tie it all together into a sort of more of an opinion piece than a piece of research. So I don't need to tell any of you that with a large language model, the clue is in the name. It's large. You need historically at least millions, and today probably billions or trillions of tokens to train it on. And that's fine if you're dealing with a majority language like English, which has billions of speakers around the world, and you have vast written form corpora to draw upon. But there are many, many, many languages in the world that have no written form, and that includes all sign languages. So again, most of you probably know this, but just to reinforce it. So what do you do? If you want to build, for example, a translation model for a sign language, what data do you draw on? So historically, the kind of work we do at DCAL, where you manually curating and creating a BSL corpus, it's extremely labor intensive. We had various teams of mostly deaf research assistants and annotators working on and off over a decade. And at the end of that process, we have 15% of our video data annotated. I should say as well, though, this is not just like a simple gloss annotation. This is reasonably rich annotations covering a number of different features of the language. But nonetheless, we have about 72,000 tokens to show for it. Compared to the trillions of tokens we were talking about for large-scale commercial applications, this is a speck of dust. So people are looking around and thinking, well, where can I just grab a load of sign language data from? And this is where we start to have a few concerns. So we've seen today a few people are thinking about turning to interpreted data. So this might be broadcast data where you have an in-vision interpreter on the screen and you're thinking, well, they're signing, right? So that's BSL or ASL or some other sign language. I'll just use that. And it depends on, I guess, the application and the purpose that you're training your machine learning model for. But I do just want to reinforce, this was raised earlier by Andrew and also by Rich in his introduction, interpretations are not the source language. So just to preface this before I go through these points, this is in no way a criticism of interpreters. I used to work as an interpreter myself. I trained at the Centre for Translation Studies at the University of Leeds. So interpreters are working under an absolutely colossal cognitive load. There are various models in the interpreting literature about how they juggle all of these different things. In some of them, you're spinning 18 different cognitive plates simultaneously. So you are exhausted. So interpreters will have various strategies where they try to reduce the cognitive burden. And that's the same whether they're working face-to-face in a community setting or whether they are being captured for television broadcast. And a big chunk of the interpreting studies literature is around how do you assess the quality of what an interpreter is producing and what kind of training strategies can we come up with that help interpreters manage this kind of load and improve the quality of their output. So this is all stuff that is very well known to interpreters. In fact, our colleagues here are probably more aware of these issues than anyone else in the room. But the kinds of things you might see in a corpus of interpreted data are just outright errors, as misunderstandings. They said a cake, I translate that as biscuit. Omissions, sometimes an interpreter may decide to, the terminology some of my colleagues use is drop something. And that's maybe more likely on TV broadcasts when there's just a time constraint that you're operating against. Other kinds of features you get with interpretations are explicitation. So that's when something was only an implication in the source language. Maybe two people are communicating with each other and there are underlying implications that you don't need to overtly state, but the interpreter who's addressing a different audience and a different culture might feel the need to unpack. So there may be tokens in the interpreted output that are not present at all in the source output. One particular area I'm really interested in is there's some really good research out there that shows, it compares the source language input to the interpreted target language output and has a look at the propositional structure of a language. So that's the sort of logical basis, the chain of inferences in a sequence of speech. And you can graph that out in a sort of interesting way. You can sort of put it into a tree-like structure, if this, then that, and because of that, and so that. And when you compare the two, you see that very often, even with highly trained, very qualified, extremely competent interpreters, the propositional structure of the interpreted output is just pancaked. It's flat compared to the very dense, very deep, propositionally rich structure of the input. If you're collecting broadcast data, you don't know a lot about these interpreters. You might be able to do a bit of background research on them, but essentially they're anonymous. They could be a second language learner of BSL. They may not have grown up signing. I myself worked as a qualified interpreter. I didn't start signing until I was about 30. Or they may be a deaf interpreter. That's more common now, but they will be working indirectly from the source language. They'll be working from an autocue. So they're already getting something that is already one time removed from the source language, and then they're converting it into yet another language, and you're treating that as if it was natural BSL. It's not. Also, we're concerned occasionally that people tend to treat broadcast captions as a transcript. They are not a transcript. People who make subtitles are operating under all kinds of limitations, the size of the screen, average reading speed, all those kinds of issues. They will make principled translation decisions about what to keep and what to drop, what to change, what to shorten, what to simplify. Ideally, you should be working with the source language where at all possible. So you might think, okay, well, I don't want to use interpreters then. Why not original sign language broadcasting? This was historically very rare, but recently here in the UK, we have things like Lumo TV, formerly the BSL zone by the BSL Broadcasting Trust. So you might think, well, great, I've got deaf people using sign language. But again, there are sort of issues around here. Yes, it's more natural language, arguably, but there are still features of it that may or may not be quite suitable for your intended use case. If, different kinds of television program will have substantial register and genre differences. Is it a drama? Is it a documentary? Is it a political discussion program? Is it a kids' TV program? Often these will be scripted, or probably with BSL, often partially scripted or workshopped beforehand. So they're not quite spontaneous. They're not quite natural language in that sense. Again, they will be captions, but in this case, sometimes now, the captions are a translation from BSL to English, and then these decisions are made about how to fit it on the screen and how many words per minute people can deal with. So again, you're not really dealing with English, or you're not dealing with a direct English representation of what was being said. And then, of course, as you know, TV shows may have all kinds of production issues. How are the signers oriented in space? Are they moving along? Are they signing while they're walking down a corridor? Are they on an alien spaceship with a red flashing light? You don't know whether that's going to pose issues for your machine vision application. So then I think worst case scenario, just randomly grab it off the internet. Maybe have a look at YouTube, think, oh, that looks like a person signing. I'll download 8.5 million videos of that. We'll treat it all as if it were BSL, but you have no way of assessing the background of the person signing. You don't even know that they're a deaf signer. They could be a level 1 BSL learner. You can't even necessarily be sure that it is a specific sign language. It might be any sign language, unless you have, a lot of time and effort and money to spend on curation of this data. You don't quite know where it's going to come from. Not to mention numerous sort of ethical issues around licensing and consent and permissions and that sort of thing. I can bake a blueberry pie and put it on my open kitchen window to cool down. That doesn't mean that you're free to take it and use it to make a profit with, if you'll forgive the slightly domestic metaphor. So, we really would not recommend this. So I've talked a lot about the kinds of things that we are a little concerned about. What do we want as linguists? As I said at the beginning, loads of time and effort spent on the curation of high quality sign language corpora built on linguistic principles. We want the tools to help us make that happen. So I'm very excited about many of the presentations I've seen today, because the sort of long-term, high-level applications are enormously exciting. But I kind of just want one tool that works, that if I'm going to annotate a corpus and it's going to take me 1,000 hours to annotate 20 hours of video, what can you give me that will cut that job down to half the time, a quarter of the time, a tenth of the time? If we can develop more richly annotated corpora built on linguistic principles, you will have better data to train with. So there's a sort of cyclical relationship here, where if you give us the tools we need to create good sign language corpora, you will have better stuff to train your models with. So I can't really speak on behalf of all of my colleagues. As I said, the just one tool thing is a sort of common refrain. I'm going to be cheeky. I'm going to ask for 2. I would like segmentation tools, good, reliable estimates of when a particular signed utterance starts and when it ends. So the boundaries of a particular sign, trained on a specific sign language ideally, but if it generalizes across multiple sign languages, fine. Don't expect it to be 100% accurate. If I can just get something in Elan, which is the software I use for annotation, I might have to drag them around a little bit. If it's in the ballpark, if it saves me time, it's a plus. And then once you have that, presumably sign recognition tools, but what I need is something that's matched against an established lexicon, a lexical database of signs based on, phonological principles of sign language production. That's it, really. I'm happy to answer any questions if you have any. Otherwise, thank you very much for your time.
Yeah, right. Thank you very much, Matt. You've kind of presented a lot of difficulties with the current data set collection. What would you say is better? What's the best way of doing it if you weren't doing all these approaches that you've talked about?
How do you mean? So if you were forced to use one of these things?
Well, more just, we know that to do AI work, you have to have a large amount of data.
Yeah.
And you've presented here how a lot of the current approaches aren't good enough. What's the solution?
Well, I suspect it's going to have to be a sort of cyclical, iterative thing. So, of course, you need better data to train your tools on, and we need tools to create better training data with. So, I just feel like, I'm not trying to constrain anyone's work or put any limitations on what people are trying to do, but I just think that it's chicken and an egg to an extent, but maybe just start with giving me half an egg. And then we can maybe get to half a chicken, and then we can get to 3/4 of an egg and 3/4 of a chicken, and we'll get there. I'm very interested in, as I say, in the sort of high-level applications, but we're really keen to have small, useful tools that have a real impact on our work processes. That, for me, that's the starting point.
That makes sense. Thank you.
Thank you for the presentation.
Cool. Thanks, guys.
Thank you for the presentation.